This is an ancient alien object that is rapidly approaching our sun. And for the past month, all of the Earth's most powerful telescopes have been pointed at this one strange light in the sky. They have been looking for answers, but what they saw has only raised more questions. Now time is running out. Soon the object will disappear from our view, hidden behind the bright light of our sun, which leaves us with a mystery to solve. What is this thing? Officially, it's known as 3I Atlas, meaning third interstellar object, meaning it comes from away from one of those little stars that you see in the night sky. We're not sure which one exactly, but we are pretty sure that 3I Atlas comes from a very old place in our Milky Way galaxy, from a distant solar system that could be twice the age of our own sun. And this is only the third time that we've been able to spot one of these interstellar visitors. The first was called Oumuamua, this crazy cigar-shaped rock that came tumbling into our solar system in 2017. We still don't really know what this thing was, but we know it was weird. And it's already looking like 3 Atlas could be even weirder. Then there was Toe Borisov, which has become the underappreciated middle child of the bunch. And that's because it was decidedly less weird. Borisov looked like a comet. It acted like a comet, and that's almost certainly what it was. But a comet that came here from another star, which is still pretty cool. But 3I Atlas has quickly become our best opportunity yet to study a genuinely strange alien object. And this is one of those situations where the more we learn, the weirder it gets. Officially, the object was spotted for the first time on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, hence the name. At that time, it was in between the orbits of Jupiter and Mars, but still much closer to Jupiter. Although since then, we've learned that 3I Atlas was actually seen for the first time on May 7th, 2025 by the Transiting Exoplanet Survey Satellite, also known as TESS, which was busy looking for distant alien planets. So, it didn't notice our new visitor at the time. But when that first image of 3I Atlas was taken, the object was still traveling in between Saturn and Jupiter. That also helps to give us an idea of just how fast this object is moving. When NASA launched the Voyager probes on a direct course for Jupiter, it took between 18 and 23 months to reach the planet's orbit. We know that 3I Atlas was near Jupiter in May. It's now passing by Mars in September and will reach the Sun for its closest approach on October 29th. Then it will be back out at the orbit of Jupiter again by next spring. That's how we know for sure this is an interstellar object. It's traveling way too fast to be caught by the gravity of the Sun, which is known as a hyperbolic trajectory. Now, what's interesting about the observation made by TESS is that even when 3I Atlas was out beyond the orbit of Jupiter, it was already looking very bright, and then it got much brighter over the 3-week period that TESS was able to see it. That is a little weird, or it's weird compared to the comets that we are used to seeing. Typically, those comets are big chunks of frozen water that get mixed up with various rocks and dust and gas and stuff out at the edge of the solar system. And then, as that chunk of ice starts to get closer to the Sun, it warms up and begins to melt. Now, in the vacuum of space, this process is technically known as sublimation because it's impossible for liquid to exist in a vacuum. So the ice transitions directly into gas. And that's what makes the big, bright, fuzzy halo around the comet, technically known as the coma. And this is important because our typical water ice comets will not get warm enough to sublimate and develop their coma until they pass through the orbit of Jupiter and start approaching the asteroid belt. But when TESS first saw 3I Atlas on May 7th, the object was still way out on the other side of Jupiter, and yet it was already super bright and getting brighter every day, indicating that sublimation had already begun. And based on this conversation, we know that if 3I Atlas is a comet, then it's much different from any comet than we've seen before. It's even wildly different from Oumuamua, which was infamous for showing no visible signs of sublimation at all. No coma. They're like opposites. And it's also different from 2I Borisov because Borisov did all of the usual things that we would expect a comet to do. So it was strange in how familiar it behaved for something so unusual. But as we continued to observe the approach of 3I Atlas over July and August, it kept getting weirder. The coma around the object began to form a tail, which is normal for a comet. But the one around 3 Atlas started growing in the wrong direction. It was pointed towards the sun. We know that the sun is the primary source of light, heat, and energy in our solar system. But we also have to think of the sun like a big fan. It's constantly blowing out solar wind. And this is typically what shapes the tail of a comet. The solar wind blows back the rapidly expanding cloud of gas and dust around the chunk of ice to create a long trail. It's like when a dog sticks their head out the window of a car and air pushes their face back. It's adorable. Now try and imagine if the dog stuck their head out and their face stretched forward instead. That wouldn't make any sense, right? And that's why people were kind of baffled when it started to look like the tail of 3 Atlas was forming in the direction of the sun against the solar wind. These are just some of the many questions that astronomers were trying to answer when they made the decision to point the world's most powerful space telescopes directly at 3 Atlas. That includes Hubble, James Webb, Sphere-X, which is this crazy cone-shaped satellite that studies the origins of the universe. And TESS was also brought back in to take a second look at 3 Atlas as well. It was NASA's most advanced observatory that was able to provide the best insight so far into what 3EI Atlas actually is. And again, we have some answers, but also new questions as well. The biggest finding was that the coma surrounding 3I Atlas is made almost entirely of carbon dioxide, which means that this object is not a big chunk of water ice like the comets that we are used to seeing. Although it does contain some water, but the ratio of CO2 to H2O is measured at 8:1, which basically means there is 16 times more CO2 in this object than what you would expect to see in an average comet. And the cloud of CO2 around the object is now thought to be gigantic with a radius of up to 300,000 kilometers. That's almost half the size of the sun. It's way bigger than what we anticipated based on those first observations in July. And that's also got observers thinking that the solid object at the center of the cloud might be a lot bigger than expected as well. At first, we thought that the core of 3I Atlas might be up to 20 kilometers wide. Then that was tempered down to maybe 11 kilometers. But now, based on these new observations, it's thought that the actual size could be as big as 46 kilometers across. That's big, but it's not huge. We have found comets in our own solar system with cores over 100 kilometers wide. But the massive amount of CO2 compared to the small amount of water is something we've never seen before. It's basically the opposite of what we would expect to find in the halo of a comet, so it tells us that this object was created in a star system that has very different raw materials to our own. The ratios are all wrong, which is what makes 3I Atlas so genuinely alien in nature. But was it made by aliens? There was another bizarre discovery made this summer during an observation of 3 Atlas by the Very Large Telescope in Chile. Yeah, that's the actual name. It's really big. Anyway, the VT was able to detect the presence of nickel metal in the coma of 3 Atlas, but it was not able to detect any trace of iron metal. Confused? Good. Iron and nickel are natural partners. They are the most abundant heavy metals in the known universe. And that's because they are forged in the hearts of dying stars and then blasted out into space by the power of supernova explosions. It's epic, and because of this, iron and nickel are always found together in cosmic places like asteroids, moons, and planet cores. The only time we ever see nickel on its own is when we, as in humans, purposely separate the two metals in an industrial process. So how did nickel find its way into a comet without bringing along any iron with it? Good question. We don't know. It's pretty weird. So, of course, that brings us around to everyone's favorite explanation, aliens. There is no shortage of theories out there about what kind of artificial spacecraft we might be looking at. And in fairness to those theorists, it's not like they're just making stuff up. All that they do is take the known data and create a slightly more speculative interpretation. For example, we know that 3I Atlas got brighter as it passed by Jupiter. Yes, it was getting closer to the sun, but that doesn't account for anywhere near the amount of brightness that was added. So this could be explained by early sublimation due to the object's unusually high CO2 content, or it could be an alien space probe that started switching its lights on. We've also seen the theory put out there that the object is surrounded by a cloud of CO2 because it's a giant spaceship full of living organisms that are breathing out CO2 just like we do, and they are venting the waste produced into space. I've even heard it said that 3 Atlas might be a giant living organism itself, and it's consuming dust and gas as it moves through the solar system and releasing CO2 as an organic byproduct. And the cool thing is that as of right now, no one can say with 100% certainty that this is not true. It's probably not. But same thing with the nickel metal. No one can say for sure what's going on with that finding. So you can't say definitively that it's not an artificially constructed alien spacecraft. Again, it's probably not, and this is why scientists and astronomers are quickly trying to learn as much about 3I Atlas as they can in the small window of time that we have available. We have an opportunity to get a photograph of this object as it passes close by the planet Mars in early October, coming within about 28 million kilometers, which is still pretty far, but it's close enough for 2 European Mars orbiters to get a decent look. The European Space Agency will use both the Mars Express and ExoMars Trace gas orbiter to observe 3 Atlas using high-resolution cameras and color imaging systems. Now, it's not like we'll get a beautiful close-up or anything, but there should be just enough resolution to distinguish between the cloud of gas surrounding the object and whatever is at the center of that cloud. So we could maybe get an idea about what the shape of the object actually is. And then by late October, from our point of view on Earth, 3I Atlas will pass behind the Sun, and we won't be able to see it again until December, at which point it'll be on the way out of the solar system again. But we'll get one last chance. On March 16th, 2026, 3I Atlas will fly past Jupiter at a distance of 53 million kilometers. Still pretty far away, but we do have one active probe out there in the orbit of Jupiter. It's called Juno. It's an older spacecraft. It's been at the Jupiter system since 2016, and the end of the probe's scientific mission is actually scheduled for September 2025. NASA was planning to just crash the probe into Jupiter to dispose of it and see what happens along the way. But another potential end-of-life mission could be to try and intercept 3I Atlas on its way out of the solar system. So, as weird as it's been studying this object so far, we are not done with it yet. There's still a lot to learn. We will get answers. We'll probably also get just as many new questions. And that is what makes this all so fun.